Hey there, and welcome to Deep Learning for Python Developers. We're going to take a look at a lot of deep learning techniques with a focus on Python programming and explore a couple of different frameworks. I'm CTO of GLG, the world's largest one-to-one professional learning membership, and I've been working with artificial intelligence and machine learning in nearly all the applications that I've built over my 20-year career, and in particular was an early adopter of TensorFlow and Keras to build machine learning models into the work that we do. Let's have a quick overview of the course and let you know what you're going to be learning inside of these videos. We actually have 5 sections to look at here. In the first section, we'll be getting started with deep learning. And then in the second section, we're going to move on and look at MXNet and TensorFlow. MXNet being a relative newcomer, which is interesting and has support from Apache and Amazon, and TensorFlow being the more famous of the two with large-scale support. Once we've got some basics and our ability to use these frameworks out of the way, we'll actually learn at building and improving deep networks and explore a set of techniques that you can use as a normal application programmer to introduce machine learning into your software. Once we've done that, we'll peek under the hood a little bit about exactly how and why machine learning works by exploring learning optimization algorithms, and we'll even hand roll our own lightweight learning algorithm that works on a few variables so you can see what's involved. Finally, we'll take a look at hyperparameter tuning. So inside of a model, there are parameters, which are the numbers that are actually learned by machine learning. But there's other aspects of your models that come into play too, parameters that are outside of the main model itself. And these are called hyperparameters, things such as the structure of the network, the learning rate, and even your choice of algorithm. Now, throughout these videos, we're going to be doing a lot of work with IPython notebooks, which are the standard format and tool that you see for machine learning programming across the internet. We're going to be doing a lot of code inline. We're going to be making graphs, showing images, displaying text, and actually watching interactive machine learning algorithms take place. You'll find that IPython is an indispensable tool, and getting a feel for it as you go through these videos will be a skill that will serve you well in the future. We're also going to do some straight-up Python coding, particularly making a command line program to generate music files with a little program that I call MIDINet. It's actually fun to experiment with digital music, particularly when you actually realize that it's just another bit pattern, whether it's an image or a string of text or an audio file. You can use machine learning on anything that can be rendered into bits. And we'll be exploring code inside of VS Code, which is my current favorite tool for programming, but you can certainly use any code editor you want in order to explore these files. They're all published on GitHub, so you'll be able to download, fork, and branch them as you need. In order to get going with this, you should have some experience with the command line shell and Python scripting or application development. We're going to be using Python for all the code throughout the sections. When you finish, you'll have a good comparison of MXNet and TensorFlow against Gluon and Keras and get a sense as to which framework works best in which scenario. You'll definitely learn how to understand how to prepare data for machine learning, particularly loading up data with multiple different formats, including image, text, and audio, and then build working neural networks that can make predictions on those data types. And we'll make some tips and tricks for optimizing your models, kind of a first-order thing along the way, and you'll get a sense not just how to make a basic model like the multi-layer perceptron, but using current techniques such as normalization, dropout, and regularization in order to make an even more accurate model.